Find the technical discussion?
The technical discussion was good. It was specific with each industries are concerned, and it was with a wider range. It is not specific to only galvanizing, and we got a complete gist of other industries around which is linked with galvanizing. And towards the, I think that should be.
And one best thing you liked about the show?
It was techno commercial, which I liked about the show. It was not only technical, and it allowed the industry to collaborate with the backward and forward integration. So I like that particular part.
Any suggestions you would like to give for the future event like this?
The future events, I think more participation is required, and a larger audience a with a expo kind of an event which allows suppliers to be a part of it instead of coming and trying to network. An expo kind of an event would help this industry far more with the technical side, which supports the entire techno commercial part.
So, in short, you need more participants, right?
More participation is always better, right?
And how did you find the overall event management? Would you like to give any ratings for that out of 10?
Oh, it was brilliant. It's quite well organized, and I think everything is running smooth. The stage looks fabulous, and the sit down, everything is perfect.
So, did you like enjoy the gala light yesterday?
I missed it, so
Okay,
but
you missed
it was quite loud. But I got a feedback. It was quite entertaining, and the guest along with me enjoyed the yesterday night.
So, how much rating would you like to give out of 10?
I think it was 8+. It wasn't bad at all.
Thank you so much. Have a nice day. Thank you.
Doug oversees the product research and market development programs for International Zinc Association, and his areas of responsibility include hot dip galvanizing, zinc energy storage, zinc oxide application development, amongst others. Doug also provides technical and marketing support to IZA's regional offices and member countries around the world. Doug has extensive knowledge of all zinc end users and has authored numerous technical papers on zinc applications over his 22-year career. So with this, once again, welcome everyone after the lunch break. We will now be beginning with the technical session looking into various aspects of zinc and galvanization and other avenues available. And we'll be first hearing for galvanized rebars for sustainable infrastructure, requesting Doug sir to please join us. With a round of applause, everyone, let's welcome Doug sir.
Well, thank you for the kind introduction, and good afternoon. It's a pleasure to be up here again to talk about some of my favorite subjects. This is going to be a combination presentation. I will talk about rebar, and then I also have a presentation on new and what's going on with hot dip galvanized applications. So I'll try to do both those presentations in the allotted time for one. As far as galvanized rebar go, we've had a number of discussions already about the subject, and it's great that there's, I think, acceptance that galvanized rebar is excellent performance and is the way that things should be used, especially in marine environments. But what I want to do in this presentation is just share some of the technical reasons why galvanized rebar is so effective. The zinc industry has done a lot of research over many years, and some of the findings confirm or will show you why galvanized rebar is so effective. We've been through this before. You know, there's two conditions that will cause rebar in concrete to corrode: the carbonation, but maybe the more problematic one is chlorides. And once the chlorides in concrete reach 0.5 kilograms per cubic meter, that's the threshold when black steel will start to corrode. And once the steel starts to corrode, the damage that occurs is really irreparable and causes fundamental damages to the structure. And of course, this is because of the expansive iron oxide that causes the hoop stresses. Concrete's very strong in compression, but weak in tension. So when you get the corrosion products building up around the rebar, it's going to crack and spall the concrete. So what happens when galvanized rebar is placed and in wet concrete? Zinc is a reactive coating. The corrosion products of zinc, though, are protective and protect the underlying zinc. And that's what happens in atmospheric conditions, but it is also what happens in wet concrete. But the chemistry is different. The concrete is very alkaline, and the zinc will react with that alkalinity, and it forms these calcium hydroxyzincate crystals. These crystals form immediately, but the reaction only happens for a short time while the concrete is wet. And these crystals are important because they actually act as a barrier that protect the underlying zinc. And we've done research on this, and this is an indication of the reaction that takes place. You can see that in wet concrete, the corrosion is only happening in the first 24 hours when the concrete is wet, and then the coating passivates and you get no more reaction. The other thing is the consumption of zinc is very small. On the vertical axis, we see this is the amount of microns of zinc that are consumed. And at the top is 1 micron. So the consumption of zinc is less than a micron on a coating that's probably 100 or 150 microns. So less than 1% of the coating is being consumed in this initial reaction. And then once that reaction has taken place, the coating is passivated and no more reaction takes place, and you get this long-term performance, which we've already shown in earlier presentations. So how does galvanizing protect rebar? We talked about this protective hydroxyzincate coating. The zinc coating also has a much higher threshold before the chlorides will attack the zinc, anywhere from 2 to 4 times. So, you know, concrete is a porous substance, and the chloride levels do build up over time, but the zinc is much more resistant to any corrosion taking place because of this higher chloride threshold. If the carbonation is an issue, the reduction in pH, where that will cause the black steel to corrode, it will not cause zinc to corrode. And in fact, as the pH lowers, it's actually a better environment and more protective for the zinc. There's also this concept, or the issue that the corrosion products are this term friable, which was a new one on me, but what it is saying is that these corrosion products are able to diffuse into the concrete matrix. So this further dissipates any stresses that would be caused by the formation of these corrosion products, and it also helps in terms of enhancing the bond strength that the galvanized coating has with concrete. And of course, as we've talked about previously, the ability to provide cathodic protection if in certain circumstances there is a break in the zinc coating, the coating will not be undercut because of this cathodic protection properties of zinc coatings. And here's an example. This is a micrograph. On the left-hand side is the white zinc coating, and beside it is the cement matrix of the concrete. And you can see this lighter gray phase in the middle is an indication of these zinc corrosion products that have actually diffused into the concrete, and just confirming what we said earlier about the way that it can dissipate any stresses that would be caused by the corrosion of the zinc coating. And what this means, or one of the properties, is you get excellent bond strength between the galvanized rebar and concrete. In fact, it's better than black steel and a number of times better than epoxy coatings. Epoxy coatings are the main competitor for galvanized rebar in terms of protecting rebar against corrosion, and is certainly in North America one of the what galvanizing is competing against. So this bond strength is one of the key reasons that people have moved away from epoxy and are using galvanized rebar. And here's just one other example. This is an SEM of a concrete surface after a piece of galvanized rebar has been removed. And you see this dense interfacial zone indicating, this where these zinc hydroxide crystals are. But more importantly, the area to the right is where the rebar, when it's been removed, has actually pulled some of the concrete with it. And it's just confirming this excellent bond strength that you get with the galvanized, with the zinc coating against the concrete. And then, of course, the sacrificial or cathodic protection, and this is similar to what we saw earlier when we were talking about the structural atmospheric coating exposures. And then we can kind of graphically look at this. What are the kinetics involved in the corrosion process of rebar? And we can see here on the left is what is happening with the black steel, where the black steel is passive, it's not corroding, until there's a certain chloride threshold that is reached at a certain point in time. The iron starts to corrode, it builds up stresses to the point where the concrete cracks. So this is much different with the galvanized coating. Because of the higher chloride threshold, there's a great longer time before you get any corrosion of the zinc. When the zinc does start to corrode in a very high chloride environment, it corrodes much more slowly than the iron, and it doesn't build up the stresses in the concrete that cause the cracking and spalling. So this is, a graphical representation of what's happening and the reason why zinc coatings work so well on rebar. And these are just, in North America, galvanizing has been competing against epoxy. So this slide is talking about galvanized rebar, how it can be treated just like black rebar. And this is very important for field installations where, of course, the rebar is rubbing against one another. So the toughness of the zinc coating is really critical. And here's just a table comparing galvanized rebar against epoxy rebar on all these different attributes. You can see the picture of new epoxy rebar delivered to the job site, and even before it's been installed, there's been damage to the epoxy coating and corrosion of the underlying steel. So in many of these key attributes, galvanizing is vastly superior to an epoxy coating. I'll show one example, and this is from North America, and it's in some ways not so applicable to marine environments. One of the key things in North America, in the northern states, is the use of de-icing salts, which is pouring salt onto the road surface, and this creates a lot of damage into the infrastructure in North America. In this particular example, this was a bridge deck built in 1973. And 30 years later, after it was built, they were removing the post and beam center barrier, and they wanted to do a pour-in-place concrete barrier. So this necessitated them jackhammering off the concrete off this rebar that had been in place for 30 years. Measurements of the concrete showed a 2.5 kilograms per cubic meter of chloride, 5 times the chloride threshold for black steel. And basically the rebar was in its original condition. Coating thicknesses were well above the required specifications. There was no need to replace the rebar, and they just poured the concrete barrier over the existing rebar that was already 30 years old. So finally on rebar, I just would direct you to their IZA has a galvanized rebar website, and it's full of all the information that's being presented here and more. So there's an online reference specific to galvanized rebar that's available to you. So I'll move on to my second presentation now, and we're looking at global applications and new developments in general galvanizing. Oops. So I think one informative look is to look at a mature galvanized market, which is Europe. Europe is well ahead of Asia and North America in terms of the intensity of use of hot dip galvanizing. And here's a graph of the different market segments, which kind of gives you a picture of where there's opportunities in the Indian market. The other thing I would say that's important here is the galvanizing industry really is different outside of India in that most of these galvanizers are what we call job shop galvanizers. They're not steel fabricators. Their sole business is galvanizing. So it's critical for them to displace paint coatings because that brings the business to them in galvanizing. And I think this is enhances or is one of the reasons why the hot dip galvanizing industry is so developed in these markets, because they've actually actively promoted the coating and it's become really the default coating for many applications. So we just quickly go through some of the applications. And you know, these are ones that you've seen before, and particularly on the electrification and towers, you know, there's obviously a number of companies here that do that. And I think in this case, it is how do you get more of it used in India and displace some of the painted structures that are being used. But, you know, what about the substations? Again, just without question, all of this is hot dip galvanized. I'm not sure this is the case in India. And again, we're getting into, when you get into these types of structures, you know, this is steel that the tower people don't fabricate. So where is the galvanizing service to galvanize the steel that you need to build these structures? So it gets into the fact that, you know, without a lot of job shop galvanizing in India, it does limit or hurts the ability to develop the galvanizing market, in my opinion. And again, these are applications that we've talked about and obviously are being used in India. We'll just keep moving. So roads and highway, again, these are well-known applications, but they're not necessarily being used in India. So again, the opportunities and potential are tremendous. And we'll just move on. And again, to just show you some examples of bridge and highways and the support structures, the safety barriers and railings, all bare hot dip galvanized steel. Of course, they can be painted if you want to, but it's not needed from a performance standpoint. Again, elevated structures, pedestrian walkways. Again, we're getting into structures that the integrated galvanizers, you know, I don't think are going to fabricate. So you really need a separate galvanizer that can work with the people that fabricate these structures to do the galvanizing. Water drainage, big area for galvanized steel, gratings. I don't know if you use galvanized steel culverts. This can either be made by a heavy coated continuous galvanized sheet or a structural plate that is hot dip galvanized. And of course, industrial installations, tremendous consumption of galvanized steel. Some of the examples here, commercial and residential buildings, and we saw this in the magazine that was handed out at the beginning of the conference. The Europeans, because these previous applications are just a given, they spent a lot of effort in the last 20 years working on architectural applications to expand the market for hot-dip galvanizing. And these are just quickly some examples. Stairwells, building structures, canopies, and then we get into some really architectural designs, lattice structures around buildings. One interesting new market developing in China are utility tunnels. So these are galvanized, large galvanized structures so all of the utilities and electrical conducts and things that feed the cities can be all underground, and it's something maybe that might be applicable in the Indian market. You can see the rapid growth in terms of the total number of kilometers of these utility tunnels being installed in China. So this is one of the new emerging markets for the Chinese galvanizing industry. So just quickly in conclusion, I think we all agree about the enormous potential for galvanizing in India, of course in tonnage, but new applications, and I say new in quotes because they're not necessarily new in Europe or maybe North America, but they're not being used currently in India, so it's certainly an opportunity. And in my opinion, I think to realize some of these newer applications that go beyond the scope of the integrated steel fabricator, galvanizer, tower builder, I think you need independent job shop galvanizers that can work with the fabricators of these new structures to provide the galvanizing service. I'd also say that, there's a lot of resources that can be used to convince people to galvanize their structures, and there's, associations of galvanizers around the world whose job is to educate people on the advantages of galvanizing. IZA certainly does that, and there's a tremendous resources available online that you can make use of, but you have to have the incentive to go out and be convincing people of the advantages of galvanizing and convert them away from paint coatings, for example. So the resources are there, but it needs to be implemented locally, and that's where we can help, but the industry has to be there to communicate that message. Okay, well, thank you for your attention, and I'll conclude with that. Thank you. Was I too quick? Oh.
Thank you so much, sir. Thank you very much, sir. A round of applause to thank sir once again. So we'll be having you back with us on stage once again once the session, all the presentations are over for the Q&A. Now, going ahead with the agenda to learn on galvanized rebars and looking at a comparative study of the same, we're delighted to have with us once again on stage with us Professor Anand Khanna. May I request Professor Anand Khanna to join us here on stage, who has worked at the prestigious Indian Institute of Technology, Bombay. He's currently the chairman of SSPC India, which is a professional body looking into surface engineering and coatings. Sir has guided several PhDs and master's students, and he has his publications at various national and international forums. So at the start, to know more about galvanized rebars, a comparative study we have amongst us after the panel discussion. Once again with us, Professor Anand Khanna. With a round of applause, let's welcome Professor Anand Khanna, please. Professor Khanna, please. Professor Khanna, I'll just take a moment. We'd like to request everyone that during the session, please take a moment out. Outside the hall, that's in the pre-function area, we have two tablets placed for you. Please find time to submit your feedback. We look forward to some very positive, encouraging feedback from you all so that we can mount our 4th International Galvanizing Conference soon for you all on a much bigger and a larger scale, taking takeoff from the great experience that we are having for our 3rd International Galvanizing Conference. Once again, please do find time. Outside we have the tablets placed. Please do submit your feedback. We look forward to very encouraging feedback from you all. Once again, thank you. Apologies, Professor Khanna, for the small thing. Once again, requesting Professor Anand Khanna for his remarks.
Good afternoon to all of you. There were a lot of changes going on, so my title has also been changed, but I will better give you a more information about the role of zinc in improving the corrosion protection of the steel structure. I mean, I'm not talking of rebar alone, which Doug has already given you a very deep information, but I will just try to tell you, in corrosion protection, in addition to galvanization, how zinc is very much useful to prolong the life of the structures, open structure or concrete structures or automobiles or any kind of a thing. I think this is a very basic slide. I thought somebody should discuss about this thing, why zinc? The people who have, I think in your graduate studies or so, you must have been exposed to this diagram, which is called EMF series. It gives you almost all the metals in the periodic table, and it is listed in terms of the most active metal at the bottom and the most noble metal at the top. And if you see here, the steel is the most usable material, and it comes somewhere here, which has a potential of minus 0.440. And then you find below this, we have zinc, aluminum, and magnesium. Now, zinc being more active or more anodic to steel, that is the most important factor of zinc which is utilized to make our life protection from corrosion. So this is the most important fact. Of course, you will say aluminum and magnesium are also important. Definitely aluminum and magnesium are being used. But the problem is aluminum is not that cost effective, it is more costly, and magnesium has a role in cathodic protection in special applications, not all the application. But zinc is one which has the cost-effective solution to give the protection of that. So that is one of the reasons, the crux of the whole thing, that why zinc is important. It comes from this very important slide. I need not say much about the galvanization process. You all have seen and discussed this thing several times. But the most important part of this thing is how zinc coating is different than others, or different than even thermal spray or many other things. If you see here, the bottom slide here, you see that it gives that when steel is dipped into hot zinc, it is not that it simply makes a coating, it has a chemical reaction. And that chemical reaction gives a series of layers of different iron and zinc composition, which shows that the zinc is not simply sitting over that, but it is reacting. And this is the most important fact, which differentiates that if a coating is becoming the part of the metal, it is very important. But if it is simply lying on that, it is not of that application as that. And that is the basic difference when we talk about thermal spray versus this. In thermal spray, whatever you do, whatever temperature you go, there is always a mechanical bonding into that. Here it is a chemical bonding. And this is the most important part by which the galvanization becomes a very important coating method into that. Advantages, I think I will be repeating part of the things, is the first step to convert immediate prepared hot rolled coils into the hot dip coil, thereby save the steel from corrosion. And that is why today, one of the most important application of the steel industry today is that next to their rolling plant, they start a galvanization plant or color coating plant. So that minimum amount of steel has been converted to corrosion. So that is the advantage, and that's this I think most of the steel industry has learned and they are practicing it. And that is the reason today almost all steel industries have this kind of a facility to work on to that. And then we have seen the application in structures, in electrical transmission lines, automobiles, reinforced structures. Now, Mr. Doug has already covered all these things, but some slides may be common, but the important thing here is I'm trying to do a comparison with other technologies. So, you all know that if we have to create a complex, multi-story, 100-story, another kind of things, simple concrete cannot work. Why simple concrete doesn't work? Because it has only compressive strength, it doesn't have tensile strength. Under the seismic activities or so, the building can just crumble. To give the tensile properties to the reinforced, to the concrete structure, we reinforce steel into that to get a reinforced concrete structure which is stable in many seismic activities. So, the problem is that when such kind of a steel is embedded into the concrete, initially you don't have any problem. Why? Because the concrete is basically alkaline material with a pH of 10 to 12.5. Under this condition, steel is in passive state. And because of this, the steel doesn't corrode. However, because of the ingress of pollutant and moisture through the concrete cover, when these pollutants reach at the concrete steel interface, the pH falls. As a result of this, the corrosion starts. Doug showed very nice slide that when this process occurs, you get corrosion products which have more volume than the metal, and the initially cracks starts, and finally, it reaches to the spallation stage. That is the stage which reaches in this form. These are the various examples of initiation, then goes further like this. And when the plaster starts falling, that is the worst situation into that. This is the kind of a situation which we have seen in IIT Bombay. The plaster used to fall, and many people had accidents like that, And we had spent more than 16 crore rupees so many years ago to repair all this kind of thing, but it doesn't work. So it means that you have to take care of this thing right in the beginning. I'll just give you a story. Very recently, in the last 1 or 2 years, we are making a lot of structures in India. Ambedkar statue and Shivaji statue and the great Sardar Patel statue. And when these statues came, the people started coming to us. Can you give us a design which can give you 200, 300 years life? That is the kind of question coming into there. But nobody came. Can we have a bridge which can have 300 years? Nobody came. So this is the difference between a utility structure versus our old reverend past leaders. Anyhow, but when the challenge came, we created a model. And this is the model of a concrete structure, where I show that there are the three boundaries. The boundary number A, the concrete cover through which the pollutant go inside. Boundary number B, where the pollutant reaches, and boundary number on the B on the other side, at which the reaction occurs, and that is basically rebar. So here today we have lots of facilities. You can have a black bar which can have a life of 7 years to onward or so. Then you can have TMT bars, then you have CRS bars, then you have fusion bond epoxy, stainless steel, and galvanized bars. So based upon that, we had proposed recently, if you use duplex stainless steel as this thing, you can get a life of 300 years. If you use ordinary stainless steel or ferritic stainless steel, 120 years. And if you use fusion bond epoxy or so, 30 to 60 years. Galvanized thing, we have given a rating from 60 to 100 years. So that is the way in which this model was created, and there is not much time to discuss that. So what is the advantage of rebar? I will show you the second picture in yellow. In 90s, I was one of the person who was promoting fusion bond epoxy coating. And we used to use this curve to show that galvanized steel is useless. It has two-edge dissolution thing into that. And today I can tell you, I am going to use the advantage of this. That as long as you keep your structure within this range, there is no fear of the structure to go bad. And as a matter of fact, there is hardly any possibility where the pH can fall less than 2 or 3 in a concrete structure, unless there is a hole and damage like that. And 12.5, beyond 12.5 also it is not possible. So as a result of this, the structure is really stable, and this can be very clearly shown from these two examples. Again, these two slides are common, which Doug showed, but in a different color code. The first thing very clearly shows, this is the green is the chloride level, and this is the black bar. So for black bar, you require very small amount of chloride when the damage starts. But when you take a galvanized bar, you see the level of chloride is this. And that very clearly shows that the old myth has gone, which shows that to a greater extent, the galvanized bar can tolerate much more level of the chloride into that. And in the same way, if you compare black bar versus the galvanized bar and the epoxy thing, the slip resistance of this thing is much better than that of that. So this confirms to a greater extent. And again, what I have told in the previous slide is confirmed from the fact, again Doug told very nicely onto that, when you put a galvanized rebar into the concrete, the first fraction of microns reacts with the concrete and creates a very nice bonding. And that is the reason that the bond strength of this thing is very, very high. And this is a very positive thing which makes rebar useful for that. Now, somebody was discussing the other day, there are no proper standards. As far as galvanized rebars and other materials, the standards are very, very clear. The thickness-wise, the GSM-wise, and what is the procedure to be used, everything is very clear into that. So today, there is no direct from this, that there is no guidelines or any kind of thing that is not there, and one is very nicely can show the whole thing. Now, that was the topic of my talk. Compare various kinds of rebars. So we have compared black bar, TMT, fusion bond epoxy coating, stainless steel, and galvanized. First step, handling. Handling of, the only problem in handling is coated bars. Now, you will also ask, galvanized is also coated bar. But then we know that galvanized bar also has a property of taking care by cathodic protection. If any damage occurs, it takes care of the cathodic protection. So galvanized steel has no problem of handling. As a matter of fact, all metallic or other things have no problem like that. Holidays and pinholes. Again, this is possible in case of organic coatings. This problem is again not there in the galvanized thing because it is a metallic coating. Then bond to concrete, very, very strong in this case. And only in the FBEC you find there is a 13% loss in the bond strength. Corrosion protection, black bar, very low. TMT again, very much similar to that. FBEC, very, very strong because it is a barrier coating. SS, it has a passive layer. While in the case of galvanized, you have barrier plus cathodic protection. And that makes it more useful for that. Cost, that is the point. People were, yesterday, Mr. Amitabh was telling, cost is a problem. I will give you the reason for that, why in India, galvanization process has not come to that level. If you see the cost today, stainless steel is the costliest. FBEC is 1.5. If one is the cost of black bar, this is 1.5. And galvanized is only 1.65. So comparative to the fusion bond epoxy coating. But why galvanization or galvanized rebars are still not in the market? And again, I will say that in this conference also, these people are still missing, except wall mount is there and many galvanizers are not there. I will tell you from 1992 onwards, I am promoting rebars. No rebar technology, whether it is a TMT or it is CRS bars or any kind of a thing, has come just like that. It has been pushed. It has been pushed to the PWDs, SIDCOs, and so many other things into that. There is nobody from Galvanizing Association who is pushing this technology to do this thing. I think Ken, myself, and many others, we have, and Mr. Puganti, we have done lots of awareness conferences. People from this CWD, and they are agreed on that this is a better technology. But they say, nobody comes us and say, we are ready to give you 500 tons of rebars. So, Doug, this is the answer for this thing, which you are saying it is there in Europe anywhere. Here, nobody is pushing this technology. The people who manufacture this thing are not pushing it. Until and unless it is pushed, it will not come. Okay, then storage and availability. That is the point which I was telling, is the biggest problem of ready stock availability. Okay. So I don't want to just tell you that today lots of new structures have come, and the example very clearly, these examples very clearly show that today galvanized rebars can be used under the sea tunnels or many other applications. So there is really no problem of any fear that galvanized rebar will not be useful for such applications. And this is just example from the literature, which they have compared hot dip galvanized versus epoxy. You can see from 72 years nothing happened, while here the problem occurred from 12 to 24 years or so. And there are some examples in California and other things. So these are written examples which show that is a... Now cars, in the morning we discussed it all, and I promised in my panel discussion thing, I will show you some of the slides which show this difference. Why this problem of automobile things came into that? Mainly because if you see, yesterday Mr. Duggal was telling, almost 8 states are on the seashore. So you can imagine people living in these areas. They have lots of corrosion problems. So if we have to solve the problem, we try to study the corrosion of cars in these areas. And as a result of this study, and this is again, so in India, this is the 30% galvanization we do. And in international market, this is the galvanization which is done. So that is the difference which we have to enhance to a greater extent. And when we carry out this study, we marked, as per the European, North American study, we concentrated on some areas where we took the readings and tried to find out what we have to do. And then finally, when we compare these results from 6 years study and 5 year study, you can see that the green one is the galvanized and that is the non-galvanized. So you can see the difference that makes galvanized cars made from galvanized steels. They are much superior in terms of corrosion. And in this way, again, we studied about imperfections, cracks, blisters, and other things, and perforation. So that speaks itself that the galvanized, if your car body is starting with a galvanized steel, it is going to give you better results. So basically, today, if you see, I think India is now, I think number 3 or number 4 in automobile manufacturing. It's a very big market. And if we have to go from 6% of the utility of coated steel to much higher, then India has a very big scope to use galvanized steels for those applications. Next portion is electrogalvanization. I mean, somebody told that electrogalvanization is difficult and cost sensitive, but I can tell you even today, hundreds of the small parts which are used in electronics, which are used in, many of this assembling part, they are all electrogalvanized. The difference between electrogalvanized and the main galvanized, hot dip galvanized is that the thickness here is around 10 micron or 9 to 12 micron or so. And that is the reason that if these things go near to the sea environment or so, they get corroded immediately. I have solved several problems where some of these parts are being used for the main component, and when it reached to the Europe through sea, they were corroding. So we found out a very nice acrylic-based coating. When we applied this thing, we enhanced the life of this thing from 300-hour salt spray to 1200-hour salt spray. And this is how we modified these things and work into this. But I'm trying to show that this is another way in which zinc is consumed for this purpose. Then thermal spray. I think today you had a very big talk with him. So I consider this as one of the most important method of using zinc to protect steel structures, and it can do those wonders where the hot dip galvanizing has a limitation. But if there is a structure, very heavy structure, it's a ready-made structure, if it has to be coated, then thermal spray can give you the answer and not the hot dip galvanizing. And this is where I find this is a very important thing, and it is picking up very much, but compared to Europe and North America, in India, its market is still very, very low. Hey, what happened? Oh. What has happened? Kya hua? Yes. So now I will come to the last thing. So in the whole conference, we have always talked about how much zinc is being used in galvanization. But let me tell you the amount of zinc which is used in paint coating. And I will now show you from a magic from this slide that in almost 90% of the open steel structures, girders, poles, beams, all these kinds of things, they have the same principle. You apply a primer zinc coating, you apply an intermediate epoxy coat, and then a PU coat. Now I will just give you a simple calculation. Suppose I keep an intermediate layer of 100 micron, top coat of 50 micron, and now keep on varying the primer coating thickness or the zinc in the primer coating. You will see that you can get a structure from 6-month life to 40 years life. Now how it is done? You have heard inhibitive coating. What is an inhibitive coating? Just doing some amount of phosphating. You are asking this question. Some amount of phosphating or chromating. This is called conversion coating. So in this case, the amount of zinc which goes is not more than 10 to 15%. And that is why when you make such kind of a coating with epoxy or so, your life can go from anywhere from 6 months to 2 years. Okay? Now you increase the zinc concentration to around 70 to 78%. The most common organic zinc-rich coating, which is applied on the every structure before the epoxy coating is done. Moment you do this thing, your life changes from 4 to 6 years. You change the concentration from 78 to 82 to 85, and also change a resin, then you find that the life simply goes from 6 to 8 years. There are two very special zinc-based primers available in the market, which are called Zinga or ZRC. If you use these where we have 95 to 96% of zinc, the life goes to 10 to 12 years. And now you use metallized zinc, where we put 150 micron of 100% zinc. The life simply goes to 25 to 50 years. And this is what all our windmills people are doing. In windmills, the life of structure is 40 years. They said nobody can go to that height in that. So right in the beginning, they try to do the thermal spray zinc and get a life of 12 to 50 years. And if you use a hot dip galvanizing followed by epoxy and PU coat, the life can be 35 to 60 years. So this is the magic of zinc. So people talk about paint industry. The whole paint industry is finished, has no meaning until and unless zinc has to support it. You should know that any ogni coating, if it is applied on an open structure, it is always a dangerous one, because if some damage occurs, the corrosion will start immediately. So the role of zinc to create a corrosion protection mechanism makes the life of the coating. So, what I'm concluding with, the market for the hot dip galvanized is around 12,000 crore in India. How I have calculated it? Yesterday somebody told that 10.4 million tons. So if you convert into rupees, 100 rupees per kg, you get around 12,000 crore as the market for galvanized steel in India. This can further be increased if we can use galvanized rebars, which has not been touched so far, and reinforced concrete or car body, which is again not working, and then solar module stables. One of the biggest business today, which we have to work on to that. Thermal spray market today is 400 crores. Only zinc. Now when thermal spray aluminum has come, that has pushed down the use of zinc. So that market is 400 crore, but there is a scope to increase it to 1,000 crore if some effort is made. So combined market of zinc in paint coating, the paint coating market today is 65,000 crore. Out of this, if you go for the open structure thing, you can find that the market for zinc in the galvanized primer layer is around 8,000 crore. So in all this thing, if you add this thing, you find that the zinc utilization is much higher than that. So with this kind of data, I think there is some happiness in the zinc community, and we hope that we can work for this goal and see to it the market rises further. Thank you very much for your kind attention. I crossed my time.
Thank you very much, Professor Khanna. And now I'll request Mr. Ken D'Souza, consultant IZA USA, to join us here for his address on cost of infrastructure corrosion and performance of galvanized steel at 5 locations in India. Ken D'Souza, sir, definitely needs no introduction. Still, I'll say a word. He's technical expert, galvanize and pre-paint International Zinc Association. Sir, please. With a round of applause, let's welcome Ken D'Souza, sir. Technical side, can we have the caller mic for sir? And after the presentation by Ken sir and by Pug sir, we will be having the floor open for question answer session. We look forward to some interesting insights and updates from our audience across the dais. And do remember to fill up the feedback form. We look forward to some very positive, encouraging feedback from you all for the 2 days of our 3rd International Galvanizing Conference. The tablets are outside. Please find a moment to submit your feedback. Also, please do find some time, just last moments of our third International Galvanizing Conference are there. Please do find some time to visit the stall area, the exhibition area also. Thank you. With this, requesting Mr. Ken D'Souza, technical expert, galvanized and pre-paint, International Zinc Association, for his remarks on cost of Ken D'Souza's. So I'll just do it for you. Yeah. Can we please have sir's presentation?
Hello?
Yeah, it's here, sir.
Is my lapel mic working? Yes, sir. Good. So I don't know where they got this picture from. So I didn't send it to them, so I'm going to wear it. Yeah, but I can't see anything, so. Anyways, thank you for that comment. I know I was supposed to say to make this presentation yesterday. A lot of people talked about the cost of corrosion in infrastructure and how much of the GDP does it really consume. So I want to do that. And also, for the first time, I've never published this before, but we will have the opportunity to see how how galvanized sheet performs in India. We're talking about sheet galvanizing. So here's what I'm going to cover. The cost of corrosion as a percentage of the GDP. We heard numbers 3 to 4%. I'll show you some very interesting numbers that'll make this scenario even worse. Talk about zinc coatings and its life expectancy, how we calculate life expectancy based on zinc coatings. Then I'll talk about a program that I started with IZA's help in 2013. For the first time, we started to test continuous hot dip galvanized sheet produced in India and exposed at 5 different locations in India. So that's interesting. So we'll cover unpainted and pre-painted as well. And then I'll summarize. This slide has been shown a few times. 7,800 kilometers of coastline, which means that you've got a lot of salt from the ocean, you've got high humidity, you've got warm temperatures, all of which really accelerate corrosion, corrosion of galvanized steel and steel. So I want to talk about the National Association of Corrosion Engineers. It's a US-based organization. I believe there is a very active chapter in India. So NACE, as we call it, last year issued an impact study. They call it the impact study. It costs a lot of money to buy. We're trying to get a free copy. But that report that was performed by an Indian consulting firm came up with this, and this is the 2011-2012 data. So 8 years ago, they estimated that the cost of corrosion of India's infrastructure was about 4.5%. So if you were to sort of project, this is my projection, that 2019, because of the major thrust in infrastructure spending in India in the last 7-8 years, I anticipate this will be much higher than 4.5%. So let's look at where the expenses are. They can be sort of categorized into 3 different areas: agriculture and allied activities. So wherever steel and other materials are used in the agriculture field, you've got the cost of corrosion, the far right column, 6.1% of GDP is lost. GDP in that agriculture segment is lost due to corrosion. Staggering number. In industry, and you have all these various categories, from mining, from manufacturing, from construction, electricity, all this kind of stuff. The average for that is 4.7% of GDP. This is, remember, 2011, 2012. It's much worse, in my opinion, today. And then the last one is the services industry. So the NACE study categorized it into those 3 categories: agriculture, manufacturing, and then services. 3.4%, extreme right column, and it tells you exactly where and how much was lost due to corrosion. So it's more than 3 to 4%, even more than 4.5%. So if you look at how do we compare India with countries in and around us, you know, you've got Saudi Arabia. This is the same impact study. Saudi Arabia, Kuwait, UAE, etc. Look at their numbers. They're much more coastline. They're surrounded by the ocean. And they have designed in, because of their location, they've designed in proper galvanized usage to protect their investment. India, on the other hand, like I said, 6.1 in agriculture, 4.7 in industry, 3.5 for a total of 4.5. So the impact study from NACE really says that it's 4.5%. Global, they've done it globally as well. So we're much higher than the global average of 3.1%. India is among the worst in terms of cost of corrosion as a function of GDP. And then look at Australia and Japan. I chose those two countries because their cost of corrosion is only 1.5%. It's actually less than 1.5%. And I can't prove this, but I do know that Australia and Japan have among the highest utilization of zinc in the construction, automotive, and infrastructure projects. So this is a very important problem to solve. It can save India billions and billions of dollars, and then we don't have to argue about 5,000 rupees to put galvanized on steel bodies in white. So let's look at zinc coatings and life expectancy. And I'm going to go a little quickly on this. The end uses for zinc coated steel, and again, we're talking about sheet galvanizing, continuous sheet galvanizing, not the batch, or what we call in India, hot dip batch galvanizing. We're talking about on continuous galvanizing lines, light gauge, coils of galvanized. So we have the three major products that are typically used in this market. Galvanneal, maybe not so much used here, but certainly in automotive, and then in construction, roofing and decking, purlins and girts, and commercial doors. Galvanized, a big list of them, as you may not believe that they are all galvanized, but you know, we bump into them every day. And then the 55% aluminum zinc product, which is typically used for roofing and cladding, standing seam building, Quonset huts are those curved arch buildings, framing, and so on. And of course, all these products can be used unpainted or pre-painted. So here's some typical examples, again, from my neck of the woods in Canada. Every project you go to will have a lot of steel framing, galvanized steel framing used for what we call infill framing. So it's wind-bearing studs that are carrying some load, but the main load is carried by the main structural members. Roof decking for floors and ceilings. So life expectancy of the zinc coating is basically depends on the severity of the environment, right? If the outdoor climate is severe, you can expect more severe corrosion. If the product is exposed boldly to the atmosphere or sheltered, it'll affect it. Time of wetness, the exposure to chlorides, seaborne salts. If it's indoor, obviously it's not going to be as severe unless the manufacturing building is producing aggressive fumes and so on. ASTM A653, which is sort of the IS 277 equivalent in North America, it says very clearly that the atmospheric corrosion resistance of zinc or zinc iron alloy coated is a direct function of its coating thickness. And the selection of thinner coating designs, lighter coating weights in other words, will result in a almost linear reduced corrosion performance of the coating. So while everybody tries to save money and reduce coatings, we're actually shooting ourselves in the foot because we are reducing intentionally the life of the building. So, like I said, service life depends on a variety of, or the presence or absence of all these impurities, sulfates, chlorides, nitrates. Add to that high humidity in India, the amount of oxygen present in seaborne sprays, temperature. India is a hot country, so all this increases the severity of the corrosion. I'll show you the next slide, which is based on a theoretical calculation based on 5 climate categories, and I think most of you have seen the slide. So basically, depending on whether it's an industrial, which is the black line, or a rural, which is the green line, you can expect that type of service life over a period of time. So for example, the Z120, which is the total of both sides of 120, or 60 grams per side, will give you, in an industrial environment, less than 10 years. So you can take that calculation to a Z600 coating. Again, these are not necessarily outdoor test measurements. These are limited tests, then extrapolated to deliver this type of service life expectation. Again, the only thing I want to talk about on this slide is that the standard coating thicknesses at the bottom column is, you're talking about, in the case of Galvanneal, 5 micron thick coatings, or 8 microns. Galvanized in India, the minimum amount you can use, or you're allowed to use, is Z120, total both sides, which means that it's 8 microns per side. And then 55% aluminum zinc, the 3 typical coating weights are that. So a lot of people sort of make comparisons between Z275 and AZ150 or AZM150, and when they look at them, they're both, in the case of galvanized, Z275 is about 19 microns thick, 55% aluminum zinc at AZ150 is 20 microns. So that's how people equate Z275 and AZ150. So this is really the crux of the presentation. Is when I started with IZA in 2012, I came around, spoke to a lot of the steel companies, and I asked them, because the challenge for me by IZA management at the time was how can we accelerate the conversion or the transition to galvanized from the existing state, which was very low utilization. So I went to the steel companies, I met the car companies, and there was no data. There was no Indian data available. So even guys, and I hate to say this, like Hindustan Zinc Limited, that makes almost 1 million tons of zinc a year, had no idea how much zinc is consumed per year. They had anecdotal information, but nothing measurable. So I said, well, the first thing we've got to do is generate Indian data, because it's hard to convince people with European data or North American data or wherever. So we had to make a Make in India type performance. So we started, I got the blessing of IZA, and I said, we've got to start a program. So again, no performance data was available. Everybody, however, supported us. So they said, absolutely, we will provide you with the commercial samples. We will help you choose the locations in India that you want. I did this kind of work when I was a young engineer in Canada and developed it for Canadian markets, Canadian climates. So we used a typical equation that we use. That's typically how atmospheric corrosion follows. If it's linear, N is equal to 1, obviously. So weight or thickness loss is K times T is time in years to the exponent N. So basically, we were trying to calculate what K and N were through a series of sample exposures and then due to work, and then measuring the amount of zinc lost after 1 year, 2 year, 3 year, 4 years, we were able to calculate and develop an algorithm for galvanized, Indian-made galvanized. So we selected 6 commercial production coils. Nobody knows who supplied anything other than me. And we were not interested in whose product was performing better than somebody else's. We were interested in whatever was commercially being supplied to the Indian market. So regular spangle galvanized, minimum spangle galvanized was all part of this. And the steel company said, we'll supply you the galvanized and the galvalume, or 55% aluminum zinc. So we collected all that stuff, prepared samples, 10 centimeters by 15 centimeters square, or rectangular. These were cleaned, chemically cleaned with ASTM-based solutions. The ASTM G1 standard was used, and they were measured to 4 decimal places by NPL, the National Physical Lab in Delhi. We used 5 locations: Noida, which is just up the road here; Hazira, thanks to SR Steel, gave us a spot in their complex. Tata Steel gave us a spot in Jamshedpur. We had Visakhapatnam and Cochin, again, thanks to the zinc suppliers at the time. We conducted tests over 4 years, and we developed the information. So I'm going to go through, and like I said, this is Indian data on Indian samples tested since late 2013. You see the graph for galvanized. You see the regression, the R-squared. The correlation coefficients for these are very high. Surprised me. I'm not sure, I'm not ready to stand by those algorithms until I get one extra measurement. We have an extra, one more. Steel building systems are very flexible. You can expand 300-foot segment. I'm not sure what this building is, but it's got a long span. There's no columns in here. So it's very possibly either a conventional frame building with big beams across, or a 3-inch structure. And the nice thing about PEBs is there's little or no maintenance involved. So you can get up to 91.5 meters of clear span. Building widths, you can just create, rather than go wider, you can just create the next module of building. Eave heights up to 18 meters are possible. Roof slopes, you can have a steep slope, 10 and 12 steep slope, or as little as a 1/4 and 12. That's a 1/4 inch and 12 inches of run. And you know, if you're manufacturing, you can design your bays, where your material flows, to different design criteria. And then of course you can close up the building with a variety of colors, profiles, and paint systems. Fabrication of these is all done inside the building. So it's precise, it's on time, it's accurate, and it's all computer generated. The actual drawings are transferred from the CAD to the manufacturing plasma cutter. Purlin and Girk holes are all automatically done. And then cladding lengths can be cut to length to exactly fit that building. Like I said, when standing seam roof came about in the 70s, it transformed and really propelled the amount of PEBs being developed. And that's because they had extremely good performance in high wind areas, you know, like in the US and Florida and the coastal areas. Market penetration, somebody asked the question before. PEBs in North America, and we talk about PEBs in North America, typically no more than 3 stories high, and single buildings. 37% of the buildings erected in 2009 were PEBs. That sort of declined. That was the top you know, market penetration, but it's settled at about 26%. We're trying to find an Indian number, but from what I'm hearing, it's, I think, higher than 26% of the total number of buildings constructed. So, in summary, pre-engineered buildings, the continuous member design is used to maximize the amount of member load-bearing capacities. All this to say is that you put steel where you need it, where you don't need steel, save the money. Don't put steel where it's not helping you do any or carry any load. The tapered three-plate sections are typically used. It works as a system, so a lot of components, the X-bracing, all helps to keep the system's approach to design. Being designed by computer, CAD drawings, and transferred to the manufacturing unit, it's accurate, precise, efficient, and it's all automated and efficient, and it uses almost 100% galvanized steel. So it's a great story. That wraps it up. I'm just going to scroll some, oh, okay. There were some building examples that look fabulous, all PEBs. Thank you very much.
Ladies and gentlemen, thank you for your patience till now. Now we want to felicitate a very special person and party. That is Black Riders Production, who has been our event partner for this entire conference, and they have been extremely helpful, and they have helped organize this entire conference. Please give them a huge round of applause. I would now request Dr. Andrew Green to come and felicitate Black Riders Production. Thank you. I'll request you to up to I would also like to now felicitate a very special person, Miss Amna Sharif, who has been your Master of Ceremony for this event, and has been there to engage all of you and help this wonderful discussions move forward. Please, Amna.
Thank you so much.
Well, yes, on that note, once again, gratitude so much to International Zinc Association. Thank you, and it's been a great journey. This is our third conference together, and trust me, each conference is so good to, and so it's a matter of great delight to see all of us learning, growing, and sharing more and more forward. Once again, gratitude, International Zinc Association. So once again. Must be always summed up by great minds. So on that note, to give us an overview of wherein our industry, our Indian galvanizing industry is going forward. For the overview, we have none other than Mr. L. Pugazenti, Executive Director, India Lead Zinc Development Association, Indian Galvanizers Association, and past President, the Indian Institute of Metals. A round of applause for Mr. Pug, who definitely needs no introduction in our industry, right from giving advices to several state and central governments, advising various aspects of various institutions for the realm of galvanizing. Mr. L. Pugazenti is always there. So, as some of these technical formalities. So, once again, requesting everyone, please find a moment as once we conclude the session to fill up the feedback. We look forward to, as I said, some very encouraging feedback. Your feedback and your support is like the real support that helps all of us to mount and curate this International Galvanizing Conference. And yes, taking cues from all the words that we heard in the inaugural and other technical sessions, if we have the big dream of 5 trillion economy, galvanizing has a huge role to play. On that note, for the concluding and remarks from on the Indian galvanizing industry, I request Mr. Pal, please join us. Sir, with a round of applause, let's welcome sir.
Good evening, friends. The event manager has been felicitated. The master of ceremony has been thanked. And everyone is here. And enough has been said by many speakers on zinc, galvanizing, the noble qualities, virtues. Many things have been said the last 2 days. And I've been working in this industry for quite long, really for quite long. And if you ask me to sum up, what is the beauty about zinc? My punchline would be, zinc stops rust. Zinc stops rust in any form, thermal spray, galvanizing, metal spray, zinc rich painting, sacrificial anodes. You have many forms of corrosion protection. And organizers asked me, being an International Galvanizing Conference, why not I share with you my perception on the overview of the industry. And particularly I confined my presentation to the general galvanizing sector. Galvanizing has about 4 or 5 segments: sheet galvanizing, pipe galvanizing, wire galvanizing, fasteners galvanizing, nuts and bolts through centrifugal galvanizing. Other than all this, whatever is left out in steel, that's your general galvanizing. People used to call it structural galvanizing, job galvanizing, batch galvanizing. Many names have been there, but and during that time, since zinc was being imported, foreign exchange was not available, many of the government departments, DGFT and industry, DGTD, etc., they used to think of alternate coatings to replace zinc. Can we have something else instead of zinc, which is all imported? Import substitution was the slogan of the day. And also during that time, my organization, ILSDA, India Lead Zinc Development Association, was set up in 1962 in Calcutta. Those days in 60s, there were many lead zinc development associations in many countries: Australia, Japan, India, US, UK. Everywhere you had lead zinc development associations, and most of them have disappeared except ILSDA, which is the oldest body. And what is the beauty about ILSDA? It's purely a technical body, not a trade body, not a lobbying body. We hardly have any interaction with the government except on policy matters, on standardization, or any policies for the good of the country. That is where ILSDA comes in. And we have been doing many programs, seminars, journals, magazines, shop floor seminars, regional seminars, international conferences. And I used to work with IZA for a long time, till IZA was set up in India. And even today we work together. Our objective is the same, whether it is Hindustan Zinc, IZA or ILSDA, the objective is the same: to enhance the consumption of zinc, to increase the awareness, and to popularize usage of zinc more and more in as many applications as possible. Coming to 70s, in the 70s, it was many state electricity boards, Punjab, Tamil Nadu, Orissa, most of them had their own galvanizing plants to meet their captive needs, substation structures or whatever structures they were using for power transmission. So most of the state government electricity boards, even railways, Indian Railways, had a galvanizing plant in Raipur for galvanizing of transmission line towers. So they had their own captive galvanizing plants. Around the same time, in the eastern region and many other parts of the country, we had small galvanizing setups for galvanizing GI buckets, galvanized iron buckets. I don't know whether anybody is buying GI buckets now. It's all plastic buckets, as I said yesterday. So we started in a small way, and small components, nuts and bolts, fasteners, pipe fittings, elbows, teeth, junction, etc. They were all being galvanized. And also, those small setups, they all had what is called as wet galvanizing. The flex blanket floating on top of molten zinc, which is not a very scientific way of galvanizing. A lot of fumes, and people would be dipping. And from the health point of view, environmental point of view, wet galvanizing is not a very clean operation, not a very environment-friendly operation. Dry galvanizing, where you have flexing separately, you do the drying, and then you do galvanizing, and it's such a clean operation, and you can have a clean, green galvanizing plants. And most of these small kettles, those days were all coal-fired. Again, another unscientific way of operating a unit. They were all coal-fired, particularly Eastern India, coal was available easily. So they were all having it. Then it spread all over the country. Over a period of time, we switched over to furnace oil, liquid fuels, etc., which is a better way of galvanizing. Then in the 70s, you have many steel tube plants, mushroomed, wire galvanizing plants, and also sheet galvanizing began in Rourkela and Bokaro steel plant. Both of them started having them. And in the 80s, India became an exporter, started exporting galvanized pipes, galvanized wires, wire rope sheets, etc. And very interestingly, galvanized sheets were being used for roofing, as you all know, but many hill stations, Darjeeling, Himachal Pradesh, Ooty, many hill stations where they had to carry sheets, they were very heavy. So they started thinking of thin gauge, thinner sheets to be used, which is lighter to carry, lighter to transport, and lighter to put wherever they needed. So that's how thin gauge sheet galvanizing started. It started in many locations. Then in 90s, there only we had big players coming up in power transmission line tower galvanizing, and also we started exporting many of these galvanized steel towers for turnkey projects. If you ask me, Indian companies are very well known in many parts of the world for taking up turnkey projects in power transmission line execution. At around the same time, India also, this was 1998, 99, the highway project, it was Prime Minister, late Atal Bihari Vajpayee's dream to have world-class highways in the country so that people can move around easily, not that they all depend on railways only. So the highway became a big thrust area. And he started dreaming, that is the way I can unify the country, unify the population, going everywhere. And that's how the National Highway Authority of India came. And they also started using many galvanized products like guardrails, crash barriers. And you also had many galvalume, color-coated steel sheets coming. 2002, that is a landmark in India. Till 2002, Hindustan Zinc was in the hands of the government. It was disinvested. It became a private player. Till 2002, when it was in the hands of government, there were many restrictions on expansion, any new technology induction, there were restrictions. And 2002, when they took over, since then, it has been a success story for India as far as zinc is concerned. And today, India has got, as we heard yesterday, and you also have here, today India has got the second largest integrated lead zinc producer in the world. Capacity expansion, mining expansion, power expansion, everything they have done in tandem, in parallel, and it has been a success story in India. And Hindustan Zinc, apart from meeting the domestic needs, they also export zinc, and they also make plenty of silver as a byproduct, which is a very interesting thing. And we also heard today from Valmont and many other presentations, many big galvanizing baths started coming up, 16-meter long, 15-meter long, 14-meter long, which is a good development. And in course of time, we also understood the galvanizing industry has to go for very clean operations, very strict environmental norms came into being. That's how things started changing, but we have a long way to go. If you look at galvanizing plants in Europe, enclosed galvanizing plants, it looks like an auto assembly line. It's so neat and clean, you don't see any emission, you don't see any liquid discharges. Such a neat galvanizing plant you can see in Europe. And we have one in Nagpur, Shilpa Steel, enclosed kettle, but not totally enclosed galvanizing plant. So we have this kind of plant, and we should have more and more coming up in the country. I'll go to this slide first. I think enough has been said. For galvanizing, the two critical materials are steel and zinc. Do we have enough steel? Do we have enough zinc? You heard yesterday, India is the second largest steel producer as per the World Steel Association. We are the second largest. China is way ahead. There's no comparison. There's China there. So you are the second largest producer. As a user, steel user, you are third in the world, which is really good. Though we should use much more per capita steel consumption, zinc consumption, enough has been said. So you are having plenty of steel in the country. There's no restriction, there's no limitation. Now, the steel that we are using, where is it going? What are the sectors? 62% goes in construction. Capital goods 15, and automotive, again we talked so much here, and intermediate 6, 5% in consumer durable, washing machines and refrigerator, air conditions, railways about 3%. So most of the steel goes in the construction infrastructure sector. Now, do we have enough zinc? After steel, do we have enough zinc? You can see Hindustan Zinc production, both zinc and lead, about 7 lakh tons, 700,000 tons, and they are the second largest, and they are currently almost, they must have finished by now, capacity expansion to 1.2 million tons. In a few years, they will be undertaking expansion to 1.5 million tons. So there will be plenty of steel, plenty of zinc. So where are we going to look at important points for expanding our galvanizing usage? I'll come to that later. Now, zinc in India, you saw the steel sector, now you look at the zinc segment. In India, 72% is zinc is used in galvanizing. I am not going to talk about the others. And again, galvanized steel, where it's all being used, construction and infrastructure, galvanized steel, that's 43%. It should be much more. I'll tell you the reasons. And general engineering, manufacturing sector, that's here, power 13%, that's where we are growing. Transport, white goods, you've got all the other applications. So construction is the largest sector, both for steel and both for zinc. As far as standards, I think yesterday there was a mention, today also we were discussing. Unfortunately, a mention has been made that there are no standards available. It's very sad. We started developing all these standards 30 years back. I was the chairman of the committee in BIS. I had drafted many standards for Indian Standards Institution. So they're all standard, and every 6 months we keep on bringing amendments, we keep on bringing improvements for the standards. So standardization wise, we have enough here. Now markets for general galvanizing. This is where I want you to focus more, because this is where our future bread lies in. We started doing railway electrification in the beginning. I'll talk about a little later. And later on, when we started from hydro to thermal power and more power generation, transmission, then we started transmission line tower galvanizing. The guardrails, which I mentioned, 1998, 2000, etc., the highway projects, telecom towers came much later, maybe 2000 or so. And then all these cable trays, lamp poles, nuts, galvanizing, these also came later. Galvanized rebar has been said more and more by speakers. I'll be coming to this later. And then where is the future? One of the interesting applications where government has been putting more and more thrust, more and more money is the renewable structure. Now this is where railway electrification began, 1956-61, about 216 route kilometers. That's all we did. But there was no money in the government. That's how we did, very limited. And gradually you can see we have been more or less 5,000 kilometers we have been doing electrification. And you can see at the end, 28,000 kilometers we'll be electrifying in the next 3 years. This is the latest from the railway board, from the Indian Railways. There will be more and more money spent on this railway electrification. 28,000 kilometers, big business for general galvanizers. Now, energy demand, India's energy demand is growing by a factor of 4%. Power Grid Corporation, exclusive corporation for putting up transmission line towers, came in 1992. And they own practically about 153,000 tons of kilometers of transmission line towers. They'll be, is the reminder for me? Yeah. Okay. So that's here. And then 2017, this is the transmission capacity. 2022, we will be having from 75,000 megawatt to 118 megawatt. And therefore, you will need more and more transmission line towers. And Power Grid Corporation also owns telecom towers in addition to transmission line towers. You are seeing this everywhere in the country, across the country, guardrails being galvanized, and you have got lots and lots of schemes in the country announced. But is the money flowing? No, money is not flowing so much as they say, Sagarmala, Bharatmala, so many projects, rural electrification, rural roads, national highways, they mentioned so many things, but money has not been flowing. But at least in the next few years, 6 lakh crores will be invested in the highways sector in 7 phases. And by 2022, we should have 84,000 kilometers of national highways. Therefore, there will be plenty of guardrails demand there, plus all the lighting columns, traffic signposts, railings, foot overbread. There will be many requirements on the highways. The target by the government of India is to put 40 kilometers of highway per day, but currently it's around 27 kilometers. The minister is concerned. Therefore, I think he's going to put more and more effort and energy on stepping it up. Telecom network, I don't have to say much. 1995 it began, second largest after China. That's the population, mobile subscriber population, tele-density in urban area, everyone having 2 phones and 3 phones, personal, official, etc. Rural penetration, telecom network, that is now happening. And the market size I indicated here. Again, this is another area. We're talking about 5G now, 5G from 4G to 5G. Therefore, there will be an increased usage of steel here and telecom towers. You can see the growth here, the telecom, the subscriber addition, annual subscriber addition in terms of millions. You can see how it's been growing. So that's a good sign, and therefore there will be more towers required here. This is the future renewable demand, 175 gigawatt by 2022. There's more and more of rooftop solar panels, ground-mounted, solar parks, solar farms, solar power projects. Many of them are coming in the country, and windmill also is catching up. So this is going to be the future breadwinner for our industry. I don't have to tell you more. It's all for clean energy, decarbonization, and to bring down our crude oil imports, and therefore to save foreign exchange, and also to bring down our thermal coal imports, 70% thermal power for which we import coal. So this is the reason the present government has been putting more and more focus on this. And rural electrification is another area where we want to encourage renewable energy. Currently, about 20% of our power needs comes from renewable energy. By 2030, it would be 50% from renewable energy. The ultimate potential in this country is, and what's the noise? Solar Alliance. 175 countries have joined together, and it is there very near Gurgaon. So India is the leader, and we are trying to popularize solar energy in many countries. And the FDI also is big amount here, 1.5 billion coming into the sector. So these are all the pictures I'm showing. This is from my friend Galbroy's path. You can see here all the galvanized steel structures, support structures. You have to use this so that you don't have to do any maintenance when you are having solar panels. And this is one, I think a highlight should be here. They did this project in Kuwait. One of our members, Murtaza, spoke here, and about 9,000 metric tons of galvanized steel from India exported to Kuwait for a renewable energy project. That's a good sign. And this is what's happening in the country. And in future, land may be a constraint for solar farms and parks, etc. So we have started using rivers, top of canals, wherever we can have solar panel. So we used to have wooden poles, concrete poles. Now it's all steel galvanized, as you can see everywhere here. This is becoming common, and I wish more and more such galvanized steel poles come in small cities and towns and panchayats of India. I am showing this picture particularly overseas because in India and many other places, you have foot-over bridges painted. In Delhi, you will be seeing green painted. If you go to Bombay, you will see skywalk, galvanized and painted, long skywalk to cross over. So this is overseas, and India, we should have more and more of this galvanized steel foot-over bridges. This is again from a world-class convention center is coming up in Mumbai. That's the auditorium. This is the auditorium here. And all the wall cladding and the supports, they are all galvanized, again from one of our members. This, I think, Valmont showed in the morning about a very large boiler being galvanized that is 11 meters long in one dip and taken out. Lotus Temple 1985, where I was associated by L&T and an Iranian architect. And I had seen in 1980 the Sydney Opera House where they had used galvanized rebar. So when they came and discussed with Yilsda, we said, why don't you use galvanized rebar? And that's how it came. And today, if you go and see there, you won't see any rust stain, such a clean, white structure like Taj Mahal is. And that's an excellent example of galvanized rebar. And one can talk more and more, but I would like to refrain from that. And even residential houses, coastal areas, we have started using galvanized rebar. Mumbai, in VIZAG for a power plant, galvanized rebar. I'm going to finish. Mangalore, again, coastal area, you can see here. Galvanized rebar has a huge potential in this country, not only in coastal area. In Delhi, I have seen some of the houses where concrete started coming up because the local water had high chlorides. This is one thing where you would like to see. This is a temple, the tallest temple, world's tallest temple for Lord Krishna. That's the height. And this is coming up near Mathura, Brindavan. And they wanted to use 6,000 tons of galvanized rebar. First phase is more or less over, and they have used about 1,500 tons of galvanized rebar. There is a fund constraint in ISKCON, so they are stuck with it. But I think they are going to use more and more things. And this is going to be India's pride structure in the coming years. I want to conclude with some innovations in galvanizing. You are seeing beautiful picture here, fabricated, galvanized. Can you believe this? And can you believe this one? Make in India, again galvanized by one of the galvanized Sigma galvanizers. So what is the conclusion? What is the conclusion? I think many have said India is going to invest huge, at least committing now. I hope there will be more money coming down. And steel and zinc production is increasing. The markets are expanding. Markets are growing. Traditional markets will grow. And the new market growth will be a boon. And the intensity of galvanizing in India is bound to gather. But unfortunately, the government departments who are the biggest use of steel, state government, central government, local authorities, municipal corporations, they should think in terms of more and more galvanized steel. Consumer awareness, we are stepping up, we are increasing. So new application, we are identifying, and you are also coming to us, but there is a need for continued market development strategy. That's where Hindustan Zinc, IZA, ILSD, we work together. With these words, thank you very much. And so nice having all of you. And I think Rahul would like to say a vote of thanks, I think.
Thank you so much, sir. Yes, sir. On time. Once again, a round of applause for Mr. Pag, who definitely is an institutional tower with his knowledge and expertise. We all saw about the Lotus Temple, and we also saw the Make in India icon. And so, yes, so with this, definitely with this long overview that we had, galvanization definitely has a huge future ahead, not only in the Indian market, but also looking at the global aspects. With this, lastly, but surely not the least, I request Dr. Andrew Green to join us here and tender the vote of thanks remarks. Once again, with a round of applause, let's welcome Dr. Green.
Namaskar. Before I give the vote of thanks, I just want to ask 3 questions of all of you. Did you learn something new the last 2 days? Yes? Okay. Did you meet old friends and old acquaintances? Please. Did you make new friends and new acquaintances? Excellent. I therefore declare this conference a success. And now for the vote of thanks, and for a successful conference like this, there are a lot of people to thank. First, I want to thank the Honorable Minister of Steel, the Minister of Steel for the state, our other honored guests. We had an excellent group of speakers the last 2 days, as well as chairs of the panel discussions. So I want to give a special thanks to them for giving us the knowledge and information that we obtained the last couple days. I want to thank the media for being here and making sure that the messages coming out from this were highlighted. As Raul mentioned, we had 26 stories come out in the papers yesterday, and even more today. So that is, I think, great news for all of us. I want to thank our event partners for putting on a very successful show here. It's been a very professional gathering and setting, and I very much appreciate their efforts. I want to thank our sponsors for whom this would not be possible. Hindustan Zinc, our principal partner, as well as the others. And lastly, but I would say most importantly, I want to thank the teams that were working behind the scenes and making this happen. From IZA, I want to especially thank Raul. Raul, please. I think Raul, Sumitra, the rest of the IZA team here in India did a fantastic job. As well, we worked hand in hand with Hindustan Zinc and the team, so I'd like to recognize Saurav, Payal, Deepak, and the rest of the Hindustan Zinc team. And lastly, I want to thank all of you for being here, for participating. This would not be a successful conference and gathering without your help and support. So thank you, and I wish everyone safe travels. Thank you.
Thank you so much, Dr. Green. And Rahul sir, would you like to say something? So once again, नहीं सर हाँ बिल्कुल एक once again everyone with a round of applause Rahul Sharma sir here and after sir's remark we invite the entire IZA team to join us for a group photograph memorable moment together so that we kickstart sir for our 4th conference soon.
All right. So thank you everyone from bottom of my heart that you have spared your valuable time and came here to learn new things. You met new people. It was a good networking opportunity, and thanks to everyone, all the speakers, all the distinguished guests, honorable ministers, CEOs of different companies, then event management company, our MC, Dr. Amna, Hindustan Zinc team, all the sponsors, and all the support staff who have made it success to conduct such type of big events. So thank you all, and we hope that we will meet again in the 4th International Galvanizing Conference very soon. Thank you very much.
Thank you everyone and requesting the IZA team to join for a group photograph. Thank you so much to everyone. Thank you so much to IZA team. Thank you so much Black Riders team for giving us the platform to be here and be a part of these two truly great learning and amazing days. Thank you so much.